Hi, welcome. In this video, we're going to go over some features of inheritance in C++. So let's get started. All right, so C++ is an object-oriented programming language, and it has features that are part of object-oriented programming. And some of the terms are encapsulation, abstraction, inheritance, and polymorphism. So let's review what those terms mean and talk about how that relates to creating classes in C++. So the plan for this video is to go over some of the features. There's a lot of features, but some of the features in creating using inheritance in C++, using base classes and derived classes, and then we're going to, at the end, we will just review good class design in C++. All right, so let's just go over some of these terms just to make sure we understand what they mean. The first one is encapsulation. So we have been doing that with our classes. So remember, when you create a class, you want to make your class easy to use, and you want to hide your information. You want to make an abstract data type. So you do that by using private and public. There is also a concept of protected, and protected is sometimes used for derived classes, because actually a child class does not have, a derived class does not have access to private member variables in a base class. But protected might cause issues and might not work as expected, so it's better to use private, like private member variables, and use mutators and accessor functions. Another word for that is setter and getter functions. So even if you have a base class, your derived class is very easy for your derived class to use the accessor and mutator functions. We also talked about friend functions. So we did get a little bit of, in the last module, we talked a little bit about using, for some circumstances, friend functions that are able to access your private member variables for different features. So there's a lot of things you can do, but overall, you want to make your code easy to modify. You want to hide data. You want to have control over all of your data. So you only want to give public access to the things that should be given public access. So that is the idea of encapsulation for making objects. All right, abstraction is just exposing only your essential details, which is what we just talked about. And in C++, you use classes, you encapsulate all of you control everything because it's your class that you create. You create your own data type or your own object. Create your own object in C++. You make private member variables. You make public access to anything that in order to use your class, like of course, you want to use public access for your functions and stuff, but you want to use the methods of creating an abstract data type, which allows you to, if you create your class well, you just make a declaration and you say, okay, here's the declaration. This is how you can access, these are the functions you can access, and this is what you can use. And then you keep everything, you keep control of everything that you are creating in your class. Inheritance. So inheritance gives you the opportunity to use a parent class, which is called a base class, and a child class, which is called a derived class. So there are certain things that you would have in a base class. So if there are certain things you would put in a base class. So let's go for an example. Say you have a bank account class. So if you have a bank account class, that would be your base class, right? So there are certain things that all bank accounts share. Like a bank account would have an account number possibly, and would have I don't know, maybe a branch, the name of the bank, or might have, just certain features that all bank accounts share. But then there are extra features or things that could be overridden in your derived classes. So if your base class was bank account, your derived class could be a savings account, a checking account, maybe a CMA account or different types, a CD account. So you could have this parent class, which has certain features in it that could be used by all accounts. Even in your parent class, you could have your, your display function. You could have some features that would be a part of all of your other classes, and then you can branch out from there. So you can inherit, so you don't have to reinvent the wheel, right? So if there's certain things that are going to be the same in all of your bank accounts, you don't want to have to reinvent that each time you create a new account. So keep in mind though, this would be a class bank account, then this would be a class savings account, and this would be a class checking account, and this would be a class CMA account, and it would be set up that way. So you would have a parent class, the base class, and then your derived class, which are your child classes. This also, you could have intermediate classes in between your base and your derived class. So the hierarchy doesn't have to be just parent-child. But we're going to just do for our assignment, we're getting towards the end of the semester, we're just going to do a parent-child. So hopefully you have some experience also. Inheritance is not exclusive to C++. Other modern languages also have inheritance. All right, so polymorphism. Polymorphism is the ability to handle different types of data or objects, and you don't have to reinvent the wheel. So we're going to talk about two different things: overloading functions, which we've done overloading functions with our friend functions. That's not really the same thing as polymorphism, but that is a concept of overloading functions. And we have also overriding functions. So you override functions by using virtual functions. So overloading functions, we're going to talk about the difference, but I'll just tell you very quickly. Overriding functions, the function is going to have the same name and parameters. And it goes through a parent to a child. So you might have, I don't know, you might have a display function for your bank account, but then in your savings account, you need to add different features to your display function. So you will override that function. It'll be the same function, the same number of parameters. You're just going to inherit the basic part of that function from your parent, and then you're going to add extra features in the child. Overloading would have different parameters. So the concept of overloading means that maybe you want to display a character. So then you'd have the function display and it would take a character. Or you wanted to use the function display for a double. So that's overloading. Overloading, you're not going to use the same function and change it up through a parent. You can overload functions. You don't need to be, it doesn't need to be derived. So I wanted to make sure, and I do have some slides to be derived. I do have some slides later in which I'm going to go over in more detail the difference between it, but since it was mentioned here, I wanted to just introduce it. So polymorphism also has to do with different data. So we have seen the concept of polymorphism. There's two different types of polymorphism, and the first one we've already seen has been with templates. So if you remember when we covered templates, we talked about how you can have a template class, and then that template class could be used for integers, and the same template could be used for doubles, and the same template could be used for a different type of object. So that is one type of polymorphism, is using templates that you handle different types of data. Then there's a second type of polymorphism, and that is done through derived classes. So we're going to talk about the two different types of polymorphism, and we're going to talk about and make sure you guys have an understanding of the difference between overloading and overriding. And overall, these terms, encapsulation is creating objects and hiding data, creating what's called abstract data types. And when you do that, you bundle all of your properties of your new data type into one object, and then you have methods or functions. So methods and functions is the same word. So you use methods and functions to operate on that data. You keep your data private, and you use accessor and mutator functions to access any kind of private data. And you want to have control over how your anything uses your class. So that's why you would use abstraction and only expose any essential details in order to use your class. And now today our new topic in this is going to be inheritance and polymorphism. But we have seen a little bit about the concept of polymorphism when we talked about templates. All right, so now let's talk about inheritance. Okay, so I did talk about it a little bit already. You have a derived class. The derived class is going to be the child. And you have a base class, which is going to be the parent. Now keep in mind that you can have intermediate classes in inheritance, but we're going to focus right now on just creating a parent class, understanding and deriving things for the child. So the idea is if there are things that you could put in your parent class, for example, if you wanted to make your parent class is a vehicle, and then your child, you could have a truck and a car. So there are certain things about vehicle, I don't think I spelled that right. There are certain things that trucks and cars have in common. They have a VIN number, they have manufacturer, so they would have that in common. Of course, a truck manufacturer might be different than a car manufacturer, or they could be the same, but they do have these things in common. So if there are things that they have in common, rather than reinvent the wheel, you just make class vehicle, you put those things that they have in common, and then when you define your class truck, you just add any additional features, or you override using virtual functions to override things that might be different for a truck and different for a car. All right, so a derived class will automatically inherit member variables and functions of the base class. So again, if you have member variables, like I said, like a VIN number, a manufacturer, and then, like a car might have something different than a truck. Like a truck might have, I don't know, things that make a car different from a truck, like a bed capacity or something like that for a truck, and a car might have I don't know whether or not it's has a trunk or is the style of the car or something. So those things would be different between a truck, like a bed capacity would be only for a truck, and whether it's like a car, I don't know the name of it, but like cars with trunks or car hatchback, that's what we used to call it. I don't know what they're called nowadays, but like features that are unique to cars wouldn't need to be in the parent class and wouldn't need to be in the truck class. All right, so this is what I just said. You can have additional member variables and additional member functions as needed, but things that they do share in common, you certainly don't want to have to reinvent and add again in your derived classes. All right, and it's a child. All right, so here's an example. Here's an example of this would be the base class, would be a device, and then you could have a thermostat device, and you can have a door device. So you have two different types of devices. You have your parent, which is a device, and then you can have as many different types of devices, but this is just an example of two different ones. And you will notice that this has a status and this has a status. These are overridden functions. You can override functions by adding the word virtual, which you should, but you don't have to. But what this has is, like, this has a certain type of status. but a door device might have a different way to check the status versus a thermostat device, which would have a different way to check the status, right? So like a door device, I don't know what a door device might have a camera or something to check the status, and a thermostat device might have a, is going to check temperature. So a door device doesn't care about temperature, but every device would have a kind of a status. And then the other things which they would inherit is a model. So you don't need to have an extra model, and a serial number is just like the idea with a VIN number and a manufacturer for a vehicle. You don't need to add that because a door device is going to have a model and a serial number, and a thermostat device will have a model and a serial number, and both of those devices will inherit that directly from device. All right, so parent and child. So let's talk about how this works. The child class, which is derived, the parent class, which is the base, will automatically have all the members of the parent class. The parent class is also called an ancestor of the child. The child could be called a descendant of the parent. And if you do not, if your derived class, you do not make a constructor, so we've already learned how constructors work, then if you can create your own constructor, so if you have extra features in your derived class, you would want to create a constructor for your derived class. If you don't create a constructor for your derived class, the base class constructor will automatically be called. All right. If you have a member variable that is private in the parent class, the child class cannot directly access those private member variables. So you need to use accessor or mutator functions. All right. There is this concept of protected members. So if you do protected members in your base class, then the child will be able to access those protected members. Sometimes you have unexpected behavior. So for our example, we're going to use private member variables in our parent class, and then we're going to use accessors and mutators. Also, it's very good practice to create accessor and mutator functions for all your private member variables. So this is a class, and it's just more practice. All right, so you just use your accessor or getter functions and your mutator or setter functions. Obviously, public members are accessible outside every class. All right, so let's just talk about redefining, or in other words, overriding. This is overridden versus overloading. So a function can be redefined in a derived class, and it has the same number and type of parameters. So this is called override. I hope that I spelled that right, but I said I would just go in detail again the difference between override and overload. So we're going to see examples. This is just this is the lecture part, and then in the next video we will go over examples. All right, a derived class. A derived class, you can only make one function with the same name. So if you're going to override in your derived class, so say you have a display function in your base class, then you could put a display function in your derived class and change what's happening. That's the concept of overriding. If you don't override it, it's going to automatically use the base class. The overload function has a different number and type of parameters. Okay, so you can overload functions, and you're not limited to overloading functions between a child and a parent. You can overload functions. We've already done it. We did overloading the assignment. We're doing overloading with friend functions. So overloading just means that you change the function, and if the function overload if the function has the same name, then the function must have different number and or types of parameters. So you could have a function display. You could have a function display with an integer, a function display with a string. This is function overloading. Overriding would just be the same name, same number of parameters. All right, a derived class has two functions with the same name as the base class. The two functions that it has with the same name as the base class, one is defined in the base class and one in the derived class. All right, so inheritance details. So there are some functions that are not inherited by a derived class. The functions that are not inherited by the derived class are destructors. So destructors, we haven't spent a lot of time on destructors. I did talk about it. Destructors are used to make sure that when your class goes out of scope, everything that was associated with it gets cleared up. So especially if you are doing dynamic memory, you want to make sure that that you have your destructor. So there's a couple of things. First, you could just put a destructor in your class, which is what we're going to do on our next assignment, just for practice. And you just put it in there. You don't really have to put any implementation about it. But if your class did use dynamic memory, you would need to put possibly some details on things that need to be, need to be killed or ended in order for your class to properly go out of scope or properly, be no longer running. So destructors are important, especially when you're using dynamic memory in your class. But you should also just include it just for clarity. You should always include a constructor and a destructor. Copy constructors. Copy constructors are also really used for dynamic memory. A copy constructor explains if you're going to, so if you have your object 1, you've declared an object and you say object 1 equals, you want to make a copy of object 1 and you've dynamically allocated memory for certain features that are only needed in object 1 and might not be needed in object 2, maybe you're going to have to explicitly explain how you're going to deal with that dynamic memory. So again, this is another feature of dynamic memory, but it does not get inherited. And the third is the assignment operator. Again, that's how to assign. Both of these are ways in which to assign one object that has dynamic memory to another object of the same type. So if I had two vegetables and I wanted to assign one vegetable to another, but I had dynamically allocated memory for one of my vegetables, and I need to put in there how to copy one vegetable to another and how to assign one vegetable to another. So this really has to do with dynamic memory and making sure that you are not that you're properly cleaning up your memory and using and also in C++, the dynamic memory includes pointers. So when we are copying things over, we are pointing to areas in memory, so you want to make sure that you have control. There are default copy constructors and default implementation for this, but many times you want to have control over it. All right, so let's just go over this again. So a derived class is going to, a derived class is the child. It will inherit features from the base class, which is the parent. You can reuse code, obviously, and we have polymorphism, which we're going to go into detail about what different types of polymorphism. But here's just look at an example of, you have your base class. This would be a function, show. So, and then you have your derived class, which is going to, this class is going to have this function show and it's going to have an additional function called display. So this derived class, this is the notation. Don't worry, you're going to have a template to do it. And this derived class is going to inherit everything from the base class. So the base class does not have a function display, but the derived class has a function display, and it also has available to it the function show. So here's an example of an animal class. So your base class is animal, and then so this animal, this is the, and we're not in ours, we're in our assignment, we are going to do a declaration, but in slides it's much easier to put the implementation inside here. But I really like you guys to get in the practice of separating your declaration. So the declaration would just be the prototype from the implementation. But here, just to demonstrate, it's going to be okay to put the declaration and the implementation in one together. So I'm going to stop right here and save that first video, and then we will pick up right here on our next video.